Welcome back. Question. What temperature does water freeze at? It always ends up in tests, doesn't it? And teachers are always looking for one answer. Yeah, they're looking for 0 degrees. Now make sure that whatever you learn today, that's the answer that you put, because that's the answer that they think is right. However, I've got something interesting here. I've got a bottle of water. It's just liquid water. And I can show you that just by moving it around, and you can see that it is clearly just a bottle of water. So what I'm going to do is administer the Elsa test. I'm going to get angry with it and it's going to freeze. And I'm going to get angry with it with this mallet. Yep. Okay. Clearly, life at the North Pole is what I'm destined for. Yes, I clearly passed the Elsa test. Tiny dribble of water in there, but most of it is ice. Let me hold it up next to another bottle of water so that you can see the difference. Which one is ice? Exactly. The one that I hit with the mallet. Why did that happen? Well, first of all, let me look at this another way. Here I've got a bowl, and I am going to drop an ice cube in the bottom of it. One bowl, one ice cube, one bottle of water, and I'm just going to pour it over the ice cube. What could possibly happen? Now I know what you're thinking. You're thinking, that's not water. Water doesn't do that. If it isn't water, only joking, it is just water. Now what's happening here? We've said that water freezes at 0, but we don't normally freeze water like this, do we? No. This is water that is about -10 degrees. And it's still liquid. The reason being is because water actually needs something else to help it to freeze. It needs a structure, something to remind it that an ice crystal has a certain shape. Remember back to what we learned about water. Water was an oxygen molecule with 2 hydrogens. But a water crystal, or ice as we call it, is actually 6 water molecules all arranged in a pattern, in like a hexagon shape. Now all those hexagon shapes all join up together. Think about it, if you've ever seen a snowflake, then it's always got 6 sides. Our ice here is no different. Every crystal starts with 6 sides. So how can I freeze it instantly? Well, that happens because think about what happens when you shake a bottle of water. If you shake a bottle of water, well, you see bubbles in it. And a bubble is enough of a structure to remind the water to line up. Oh, quick, we're cold enough to be ice. Let's line up. We call it a site of nucleation. So if a bubble is a site of nucleation when we shake it, what happens when we pour it over the ice? Exactly. The ice structure itself in the ice cube is enough to remind the water that it can quite happily join up. And once one crystal forms, the rest forms. That's also why you saw it spread down the bottle. Now, this is really interesting because we've learned quite a lot about water, but it answers a lot of things. If ice forms a nice big crystal, then it takes up much more space than it would as just water molecules on their own. That's really handy. If it takes up more space, then it means it's less dense, which means that ice, unlike most things that you come across on this planet, when it's a solid, it floats on top of its melt or its liquid version of itself. That doesn't work with like wax. If you melt some candle wax or something like that, and you get it nice and liquid, and then you drop a piece of solid wax in there, then you'll see that it will sink. Not so with ice. And that's really handy, because if it didn't do that, well, if ice sank, then any ice that formed in the sea would sink to the bottom. If we had no ice on the surface and at the bottom instead, then we'd have no aquatic life. Have no aquatic life, have no fish, have no fish, have no cats, have no cats, have no cat videos. Have no cat videos, no need for YouTube. No YouTube, what's the point in the internet? And if there's no internet, what's the point in living? Got a bit carried away there, didn't I? Okay, but think about how important that is in our life, and just how important it is that we actually understand the very basics of the things that keep us alive on this planet. Let's also look at some of the other things and review what we've done today. Let's look at your homework. What was the melting point of iron? Well, anything around about 1,500 degrees Celsius. That's really cold. What was the auto-ignition temperature of cotton wool? Oh, more than 400 degrees Celsius. That's really hot, just from one little piston. What polymers did you find in your kitchen? Okay, well, you might have found things that were made of plastic, you might have found things that were made of rubber, you may also have looked in the cupboard and found some foods, cheese. Oh, paneer cheese, for instance, lovely, very easy polymer to make. What about starch? Starch is a polymer, it's made of many chains. So anything with potatoes, rice, these things contain lots of polymers. So polymers actually happen naturally as well as things that we make. We've also made hydrogen like a chemical engineer, just tearing water apart, and now we've just examined how water freezes. So that's all from me today. All that remains for me to do is to thank you for being with me today. Go off and continue to be curious, looking at things in your everyday world. This has been John Wood and your High Street Science. Bye!